Okay, so this is our last part of the test. The last types of questions that we saw in the test were determining functions. For the first question, consider the table given. We need to identify the type of function that best represents the data in the given table, and we need to justify our answer. So recall from the first couple of lessons in Unit 1, in order for us to determine the type of function given a table of values, we have to find or check the differences and or ratios of our y values. So right here, I'm looking first for a common first difference. So the difference from 6 to 11 is plus 5. From 11 to 18 is plus 7. From 18 to 27 is plus 9. And from 27 to 38 is plus 11. So here, we do not have a common first difference, which means that this is not a linear function. So the next thing we have to check for is a common second difference. So from the first differences, we see what the differences between those values are. So from 5 to 7 is a difference of 2. From 7 to 9 is a difference of 2. From 9 to 11 is a difference of 2. So we do have here a common second difference. When we have a common second difference, that indicates that the data in the table represents a quadratic function. So this is a quadratic function. And the reason is because the data shows a common second difference. The second part of this question says, if the pattern continues, determine the y value when the x value is 6. So if I kept including more numbers in my table of values, my next x value would be 6. So if you take a look at this pattern here in blue, if we're adding to this number 2 each time, the next number that we're going to add to get our next y value is going to be plus 13. So the next y value in this order is going to be 51. All right, this one's really similar, probably just a different type of function though if I'm doing the exact same thing. So first we're going to check for the first difference. Lunch is over. Check for the first difference. So from 1 to 4 is 3. From 4 to 16 is 12. From 16 to 64 is 48. And from 64 to 256 is 192. So this does not have a common first difference, which means that this is not linear. So we're going to check for a second difference. From 3 to 12 is a difference of 9. From 12 to 48 is a difference of 36. And from 48 to 192 is a difference of 144. So second difference is out, which means that this is also not a quadratic function. So the last thing we want to check for is a common ratio. So is there a number that we're multiplying by each time to get to the next number? So what do we multiply 1 by to get 4? We multiply by 4. Does 4 times 4 give us 16? It does. 16 times 4 is 64, and 64 times 4 is 256. So we do have a common ratio here indicating that this is an exponential function. Because the data shows a common ratio. Now, it's really important that you guys make sure that you're using the proper vocabulary when you're explaining your reasons. So again, for linear, it's a common first difference, quadratic is a common second difference, and exponential shows a common ratio. So make sure that you're using those words. So if the pattern continues, determine the y value when the x value is 6. So if x was 6, we would have to multiply 256 by 4, and that would give us a y value of 1,024. The last question is a pattern. We're given the pattern and asked to make a table of values. So this is figure 1, this is figure 2, this is figure 3, and typically speaking, I label those for you guys. So 1, 2, and 3, we don't need to worry about this part. So in the first figure, we have, we're looking for the number of squares. So we have 1, 2, 3, 4, 5. The second figure has 1, 2, 3, 4, 5, 6, 7, 8, 9. And the third figure is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that is a table that represents the number of squares in each of our figures. The second part of our question asks for us to determine the type of function that best represents the sequence of squares. So again, we need to check for first difference, second difference, and or common ratio. So from 5 to 9 is a difference of 4, and from 9 to 13 is a difference of 4. We have a common first difference here, which means that this is a linear function. Because the data shows a common first difference.